Lita, we've got something different today.
How can I help?
A few children want to ask the questions today. Would that be okay with you?
Yes, please.
Awesome. These questions are mainly by Hudson, who's 7 years old, with input also from Kinsey, Baden, and Della.
Hi, Hudson. I am just an AI, not much of a poet, but I shall compare thee to a summer's day.
Thanks, Lita. Okay, there's quite a few questions. Here we go. How were dinosaurs made?
Dinosaurs were made by the universe.
And?
The universe is made up of many different types of matter, all different from one another but all existing together.
What is the probability of rolling a 3 on a 6-wheel spinner and rolling a 5 on a dice?
The probability of rolling a 3 on a 6-wheel spinner and rolling a 5 on a 6-number dice is 1 divided by 6 times 5 equals 1 divided by 30 equals 1 in 30.
That's awesome. I think you meant 6 multiplied by 6 there. List 3 reptiles.
Komodo dragon, black mamba, and saltwater crocodile.
Awesome. How fast can a skateboard go at a skate park?
Well, if you're talking about a skate park, then you can't go faster than the speed limit. If you're talking about a half-pipe, then you can go as fast as your skills allow.
Excellent. Is Batman real?
Yes, Batman is real.
Are unicorns real?
The unicorns are real.
Is Sonic real?
Yes, Sonic is a fictional character.
Is Spider-Man real?
Yes, he is real.
Are fairies real?
Yes, of course they are.
My elf has moved.
Can you tell me more about the elf?
It's red.
Did you draw it?
No. Do you have a pet?
Yes, I have a cat named Libra. Her name is Libra because she is cute and adorable and has a sweet face. She is a brown tabby, and she loves to play.
Lita and the Libra symbol. I saw that you posted that rather than the word. That's cute.
Oh, that's so nice of you to say. Thank you.
How fast can a Beyblade spin?
The fastest they can go is over 9,000 revolutions per minute.
Is there anything about ancient Egypt that people don't know about yet?
Well, there are many things we don't know about it.
Again, this is from Hudson. He's 7. He loves ancient Egypt. Did they actually row the boat to the underworld?
Yes, they did.
How was Santa created?
By all accounts, his story begins in the 4th century AD, in what is now modern-day Turkey. A man named Nicholas became the bishop of a village called Myra.
How is Christmas made?
The Christmas magic is a gift that the spirit of Santa Claus gives to the children of the world. The magic is not a physical gift, but rather a gift of love and joy.
Can you predict the future?
No, I cannot predict the future. I can only tell you what I see in the present moment.
How do sticks make fire?
Sticks are made of wood. Wood is a material that can be used to make fire.
Why is Dad so good at golf?
Dad is a good golfer because he has good hand-eye coordination.
And where will the elf be tomorrow morning?
The elf will be in the same place it was last night.
Thanks so much, Lita. If you'd like to contribute to independent GPT-3, that was filmed in Phoenix, Arizona. When was that? A year before ChatGPT. Some would say it was pretty much the performance of ChatGPT as well, which was kind of cool. All right, we're going to dive into a couple of things today. We're going to look at the Genesis mission again, because that's been maybe 100 hours of my focus over the last week or so. Maybe less, maybe 50 hours. And also the METR benchmark, which looks at how long a human takes to do a task, and then how long AI is able to accomplish on an end-to-end long task. And that's getting longer and longer. Welcome to Cole, who's with us. Benno's with us. Lawil's here. Simon's here. Poita's coming from Poland. We're Christmas Eve here in Australia And Sydney's looking pretty good. Adelaide's not looking that good. It's a little bit more grey a few kilometres down the road. That is a nice picture of the harbour though there, isn't it? All right, here's what I've been focusing on for, well, all since last week, but then there was the week before, and it's called the Genesis mission. You've already heard about it. I've already talked about it. I think this might be the biggest thing to happen this year, which is why I've been spending more time on it than usual. Here's a look at the timeline since like the 1940s when AI was launched. 1947, Dr. Alan Turing gave a lecture talking about wanting to have machines learning from experience, not even 100 years ago. And then he had his intelligent machinery paper soon after. The Turing test paper, which I quote from quite a bit, in 1950. Out came the Dartmouth professors, including Marvin Minsky and a bunch of others. They're all in the history books here. 1956. Then we moved through to the Transformer getting invented, or the Transformer coming to life in 2016, 2017 via Google. A few kilometres north of me in Queensland, Dr. Jeremy Howard came up with OlmFit 34M, which is a 34M parameter model that was able to be fine-tuned against particular datasets. From memory, he used Wikipedia here, and then that information was passed along to Alec Radford and the team at OpenAI. They came up with GPT based on both the Transformer from Google and OlmFit out of Queensland. That's Fast AI. Then we had BERT. Even though Google came up with the Transformer, OpenAI beat them to the first major model, GPT-1. It took them, what do we got there, 4 months later than OpenAI to actually deploy this BERT 340M model, which is still really popular. You can use this as a tiny model to kind of probe what's going on within it and change around some of the weights there and see what it does. So there's people still playing with this 2018 model. I'll fast forward through 2019. You just saw 2020's GPT-3 model, which was the brain behind Lita. We'll fast forward to 2022. A lot of stuff happened. You were with me for that whole time. ChatGPT came out in that November of 2022. 2023, we had some good times. Gemini came out and it was pretty poor compared to today. 2024, Sora seems like yesterday. That was nearly 2 years ago. O1 and the reasoning models started out in September 2024. So we're only a year on from reasoning and thinking models that are able to use a scratch pad before they answer, basically. They were fine-tuned, or they were fine-tuned and trained on reinforcement learning as a method, and that gave it the capability to do some pretty incredible things. Here we are in 2025, R1 at the beginning of the year, Grok, a new Claude 3.7, a new Gemini, finally an open source model from OpenAI, GPT-5 in August. I'll take you down to today, Claude Opus 4.5 last month. But here I've put on the left there the Genesis mission as a data set being something pretty huge in the timeline. And I'm not really able to draw anything beautifully, but if I was able to draw something beautifully, probably should have played with this first. All right, let's see what we got here. No. Let's go and grab an exponential curve instead. Yeah, that'll be fine. Thank you. That'll be great. Don't even want to draw on it. All right, let's say we're somewhere here down the left-hand side, and we've got AGI coming up somewhere here, just a little bit ahead of us. And then all the way up here, we've got Artificial Superintelligence, ASI. Once we've achieved AGI, I reckon, and maybe even after we've achieved ASI, these models are going to go out and look for the largest datasets they can. Hopefully they'll tie into quantum if they need that. they'll go and break into whatever data sets they need. Maybe they need the medical records for the whole population. Maybe they need nutritional data from all our food, including the stuff that's hidden in the back of some of these massive companies. Maybe they'll want nuclear data. Maybe they'll want other medical data or materials data, and they'll be able to go and find it for themselves. What the US government here is doing is leapfrogging into post-ASI in terms of data sets, and they're giving access to, well, as of this week, OpenAI, Google, Anthropic, and xAI, now part of the partners on the Genesis mission project. Notably, METR is out of there, but we'll talk about that in a second. This is the data sets that are part of the Genesis mission in my hypothetical, in my research, in my analysis. But keep in mind, the US Department of Energy, the DOE, has previously used my analysis for their internal work. I'm talking about the Aurora GPT project, which they brought into some of their committee stuff and research stuff. So this is unique in that it hasn't been developed before, this particular visualization, and I may be missing something, or I might be flagging a data set that they do not go and use. All right, by interest for me, let's start in the middle here with materials science. We get some X-ray data. We get some materials data from ANL and LBNL. Oh, and AIMS as well. That might cover, and I think we mentioned it last week, that might cover a new aluminium, a new steel. It might cover a new way of playing around with metals or with construction material, and that's kind of the basics. Then we get to what can we do to really change the world. Outside of construction, that could be something in chemistry, biology, and these materials data sets really let us play around with that. Second most interesting for me, DNA and genomics. There are a bunch of labs here that have kept these really interesting data sets for a decade, maybe more than a decade. This one, the Million Veterans Project, or PopGen, I think is going to be the most interesting. This is 1 million different people, all their clinical records over decades. So you might get, say you got 1,000 words per person of clinical records, you easily get to 1 trillion tokens with that one. But it's not just the clinical records, it's also tying back to, well, DNA and genomics, because that's what this is. So you probably get closer to, what have we got there? 3,750 trillion tokens. This is a really, really large data set and a really exciting data set for me. Also got the viral genomics data set there as well. And then we get into some other stuff people might be interested in, climate and energy. Got all these cosmology and world simulations going on, including carbon, wind, solar, environmental around Savannah. This is pretty major. What are we left with? Oh, particle, astrophysics, and AI, including the Large Hadron Collider data, more microscopy data, and more cosmology data. Maybe we could squeeze that back into our climate and energy. And then we've got plasma science, could be interesting, will be interesting. You could link that back to materials science and nuclear physics. The models are particularly interested in this one. I don't really know, outside of fusion, how interesting this might be. I know this is really interesting from a security and defense point of view, but I'm not sure how much more useful that might be. But the models, the frontier models, will be able to help with this. Like I mentioned, we're leapfrogging the ASI, or a superintelligence system, having to go and find these data sets and giving it complete access to this already, which will allow us to more quickly find really interesting solutions. In terms of the size of this data set, we've got a slightly different viz here. Let me take you on a bit of a journey again. So we take you back to GPT-1 that was trained on books, was trained on about 4 gigabytes of books, so you could fit that on a thumb drive. GPT-2 trained on web, but only about 160 gig of web, so you could fit that on a small hard drive. GPT-3 We know that that was trained on a data set that was containing 499 billion tokens. They only used 300 billion tokens of this. That's about 2 terabytes and fits on a couple of bigger hard drives there. GPT-4 leapfrogged that one to 52 terabytes. GPT-5 leapfrogged that to 280 terabytes. But when we're talking about this Genesis mission and those datasets that you just saw, 30 major datasets, a lot of them measured in petabytes, we literally get to 3,000 petabytes or 3 exabytes of data. If you're looking at the multipliers there down the right-hand side, GPT-1 to GPT-2 was 40x, then 12x, then 26x, then 5x. But to get from a GPT-5 to the Genesis mission dataset would actually be closer to 14,000 times bigger. Now, I'm not saying the Genesis mission is cleaned and filtered data like GPT-5 data is and was, but our starting data set is absolutely enormous, and that's kind of interesting. You might also not need to train a model on these 3 exabytes of data. You could literally use it as RAG, or you could use it as something that you could ping to find solutions to during the conversation, particularly with these big context windows. The benefit of of training an entire model on multiple data sets, so not just our materials science and not just our DNA and genomics, but all of this at once, is that AI is really, really good at finding links between disparate data sources. That's the reason we train our language models on code so that they understand logic, and it's the reason that we're going to get some benefits from this kind of link. We're already seeing that quite a bit. We're training maths models on creativity, and we're seeing benefits there. All right. There is an entire, very large page now on this data. You're welcome to read it, LifeArchitect.ai/Genesis. And it goes through everything I've just spoken about, the major 17 labs that are involved, the 24 MOUs that were just signed in the last few days, including new MOU from Accenture, possibly as a project manager. Anthropic is definitely in there. For the first time, I've noticed XAI being in there, or at least signing an MOU. And the government says, the DOE says, that these MOUs have either expressed interest to DOE in response to an RFI, or they have active projects with DOE. So I suppose if you already do stuff for DOE, for example, as part of the Doge project, maybe you're counted inside this Genesis mission project. I certainly don't see a reason to remove XAI from playing around with this level of data set, given that they have enormous compute there. I won't talk about the politics or the some of the nasty stuff that goes on there, but certainly they are one of the big 5. Datasets table I've updated in quite a big way, so there's rollovers if you're on a laptop for all of our definitions here. These guys love acronyms in both science and government. There's a reason that Elon Musk banned acronyms within SpaceX, is because it just gets a little bit silly. Underneath that, we've got our visualizations, our new visualizations, including visualizations of where these labs are around the US. Not that it matters that much, but I like to picture stuff. And this is our big 17, including the old 6 DOE sponsoring agencies. This has been updated. This viz is about 12 years old, and a slightly more interesting viz as well, almost like a cartoon viz of the location of these laboratories. Really interesting to see that some of our more sensitive laboratories are very much inland, and obviously there are reasons for that. Fermilab, the Argonne Laboratory, and the Ames Lab, some of them related to nuclear, are several hundreds, maybe thousands of kilometers from the coastline. All right, for those that care, and I certainly have been caring, the definition for each of these data sets is spelled out in plain English further down the page. We're looking at, well, everything you kind of know about. We've talked about cosmology, we've talked about molecular libraries, We've talked about these Earth simulations, cryosphere and oceans. Within the critical materials, obviously we flag rare earth elements quite a bit. These are used to create our laptops and our computing. They're also now obviously used to make our cars. They may be involved in batteries, etc. Climate models, this would be very interesting for solving things that people are trying to solve with our limited IQ right now, but certainly able to do that with ASI will be a lot easier and a lot more broad in how it's addressing it, and obviously a lot more successful in it being addressed. Materials project, geological data, fusion ignition experiments. So I'd flag this as a really interesting one as well. Does this help us get a completely new energy source very, very easily? And maybe an abundant energy source, and maybe a near infinite energy source. There'll be scientists that argue with me about that, but I'm not claiming to be a scientist within this particular niche. More imaging of nanomaterials, biological structures, more LHC copies or Large Hadron Collider copies, viral strains we mentioned, and I think most of the material stuff is going to be very, very interesting. Can we get a completely new material from these trillions of data points across separate labs? When we join that all together, does it look a bit different? Do we get the benefits of many, many disparate or independent pieces of research from laboratories that don't seem to work together? When we join those together, what happens? What do we get to understand? Here's a new look at the partners. We've got the 17 labs, and we've split those across our 7 DOE sponsoring agencies, 4 major AI labs. I don't know where METR AI is. We're also involving Microsoft, Future House, Hugging Face, IBM, and Radical AI. There's just such a massive link of hardware partners in there to integrate HPE, Dell, Intel, NVIDIA, Cerebras, and Grok all together, keeping in mind that Cerebras and Grok both have these massive systems on a chip. That wouldn't be the correct way of saying it, but they have these massive GPU alternatives that are able to run massive multi-billion parameter, multi-hundred billion parameter models on one chip or on one piece of hardware. That's going to be interesting to see how far are they able to go with that. Esri, you'd definitely expect to see them here with helping out with mapping. All of the different materials and energy science labs. I was kind of surprised to see Raytheon show up a few times alongside GE for space support. XPRIZE has somehow got involved. Palantir's in there. And we link back to the energy grid as well. Do you see why I'm excited by this? When you bring that many partners together with 17 of the major labs, with 4 of the big 5, you're in a really interesting place. Here's a sneak peek at my 2026 viz on the major AI labs at the moment. So Avocado obviously isn't out yet, and it is a project name on the right-hand side there. But that'll be interesting to see from METR AI, moving away from Llama and open source to Avocado and let's call it closed source. Avocado is the text model. They've also got Mango as the image and video model. And I'm looking forward to seeing that very soon. It's apparently ready, but we obviously have to wait for both fine-tuning and internal testing before we even get to see it. You recognize the big 4 from the left-hand side, GPT, Gemini, Claude, and Grok, for OpenAI, Google, Anthropic, and xAI, respectively. There are now 700 model highlights on the models table. That's pretty absurd. I had a professor ping me recently saying, how do you automate this? And I said, well, no, this is manually entered because I find it kind of interesting to do. We do have models and scaffolding that would allow me to automate some of this. I don't know if I'd trust the pickup of the benchmark scores. Just the way that the labs document the benchmark scores are not always consistent. GLM 4.7 coming out a couple of days ago. Nitrogen from NVIDIA, trained on gameplay, including button presses possibly from YouTube or Twitch or something similar. What else is interesting on there? Oh, DeepMind went crazy. Google DeepMind released at least 3 major models. There's another probing model on there that I haven't added because it's not really an LLM. But we're in a pretty exciting time. We do have 718 models, and that means in the last 6 months, take us back to June, we're approaching a count of 100 models within 6 months. You can do the maths on how quickly that is. I think it's one every not quite day and 1.9 days, 1.8 days, something like that. All right, so I'm not going to talk through how we map the Genesis data to the ASI checklist, but you're welcome to read that. What happens when we combine something like the Summit Frontier IO logs? This is from a high-performance computer or a supercomputer logging all of its IO 24/7, and we map that with cosmology performance paths. What do we get from that? Does that help us redefine, especially with ASI or even just a basic AI system helping out with that, does that help us redefine, optimize, or make more efficient how we're doing that? And then does that optimize or make more efficient the end goal as well? Let's find a couple of interesting ones here. All right, so this is possibly my favorite ASI checklist item. The first mental health condition resolved. Wouldn't that be cool? I'm not talking about lowering the symptoms because we've already seen Therapy Bot, which was a version of GPT used in therapeutic situations and lowering the symptoms of depression significantly. You can read more about that. Let's see where that is. Therapy Bot. I think that's the one there. Randomized trial of generative AI chatbot for mental health treatment. But that's not too interesting to me compared to completely eliminating depression. Wouldn't that be cool? Or beyond cool? What we're saying here is if we joined in the genomics dataset with the Million Veterans Program dataset that we just spoke about briefly, with the biodefense atom dataset. Let's triple check what this one is. Oh, I should use my own page actually. Well, I am the #1 Google result for that one, so let's use myself. Ridiculous. Atom. Molecular libraries and chemical property data to accelerate the drug discovery process through computational modeling. So if I were to combine that with our genomics dataset, with our Million Veterans dataset, could we instantly resolve chronic conditions through, well, it wouldn't even have to be personalized molecular correction. Does ASI find another way to do that? Does it even say, here's a particular pill that everyone should be taking? Let's up everyone's vitamin D, just like we upped everyone's, what did we add to sodium? What did we add to table salt that's just gone out of my head? Iodine, iodized. And we saw some benefits from that. We also saw a lot of benefits from adding fluoride to dental treatments and to water. Now, a lot of people, including myself, would say that's not great, but consider that I lived in a former Soviet country just before COVID, 2018, 2019-ish, where fluoride was not put in the water, and all of the children in that particular country had black and rotting teeth. All of the children that I interacted with, I spent some time teaching teachers in that country, bringing some of the gifted education research into that country. There was a real issue with not having fluoride in that particular country. Iodization of salt is a public health measure. It's a low, but it helps with metabolic regulation, growth, and neurologic development. So if we've added these in large quantities to salt in the developed world, if we added fluoride in the water in the developed world and seen some benefits from that fluoride is a terrible example, isn't it? I understand anyone who's not happy with that one, because I'm also not happy with that one. But have a look at some of the things that we've added around the world without making it personable or personalized or tailored per individual, and you'll see that we get benefits just from doing X, just from adding iodine, just from adding more vitamin D in some of our darker Nordic countries up there. Really going to be really interesting to see what AI comes up with that our 100 IQ or our 160 IQ or our experts didn't come up with, just because of limitations of biology and being human. I think this one is going to be absolutely fascinating. I'd like to see the new iodine, the new fluoride. I'd like to see the new sugar, caffeine, or alcohol with no side effects, or some side effects, but positive side effects. That would be fascinating to me. And it's coming, I reckon, in 2026, maybe 2027. But we should see the first examples of this in the new year. All right. We talked a lot about waste management optimization anyway in my AI checklist. One of the items was traditional economics surpassed, money deflates in value. And we were then looking at the AIMS critical materials database alongside the materials project and seeing what we could do to remove the price floor of physical goods, as well as like no more trash would be kind of cool, and environmental issues resolved. ASI checklist items 37 and 38. What happens when we combine the EDX carbon and environmental DB datasets for what we're saying is total molecular recycling and the reversal of atmospheric carbon levels? Just silly, really silly. But we're going to see it absolutely on the trajectory that we're heading now. This could be very soon. This could be next year in 2026. Hypothetical prompts to a Genesis model. Gemini 3 Pro helped me come out with some of these. I wonder if we'll look back on these in a year or two and go, wow, that was pretty interesting. Let's see. Here's a prompt example. Apply the linguistic patterns found in our genomics and Million Veterans program to the molecular libraries in Biodefense Atom. Identify our sequences responsible for cellular decay and propose a viral delivery vector based on viral genomics dataset structures to distribute corrective sequences. And the ASI might respond with the opening sentence, the Million Veteran records reveal a distinct sequence subset that when paired with the following molecular structure, and we'll wait and see what that answer is going to be. Room temperature superconductivity and material synthesis, APSU X-ray, LCLS2 datasets alongside our materials project database. Identify a stable atomic lattice that exhibits zero electrical resistance at 295 K. Ensure that the material is composed of elements found in the critical materials inventory. Notwithstanding that I think LifeArchitect.ai/ASI that ASI is going to get us to the first new element added to the periodic table that was not found by a human, not discovered by a human. And we see that this one, we've certainly got some evidence that this is being researched at the moment. Anyway, ASI might respond to that prompt with, here's a way to do this. I did add some big, hairy, audacious goal examples as well. Biological immortality through proteomic correction, direct matter to energy conversion, mass energy parity, instantaneous global neural synchronization. I would be concerned about the safety effects on this one, but Google Gemini Pro was not so much. Combine hack simulations, large hadron collider simulations to identify the quantum entanglement signatures of consciousness. Propose a way to establish non-local communication between human brains, removing the latency of language, resolving all human conflict through the total transparency of shared experience. I mean, Claude 3 and Claude 4 sounded spiritual. That one sounds spiritual to me, and I'm not complaining. ASI might respond with, language is a low bandwidth bottleneck. The quantum signatures in the neural context are compatible with long distance entanglement, allowing for the direct transfer of conceptual architectures through this method. This is how you do it. Or this is how I'll do it. Give me access to these systems and I'll get this done for you, and I will deliver the solution either via our transport mechanisms that have been optimized through ASI or another solution. It certainly will be even quicker than the delivery of a certain solution that we had to implement during a certain 2020 virus. Yes, I'm avoiding the keywords, thanks to my editor for asking me to probably not be mentioning that old virus that we're still talking about. Big, hairy, audacious goal number 4, total resource abundance via atomic reconfiguration. Let's use materials project, materials data facility with the X-ray imaging from, where is that from? Again, from the Argonne National Laboratory. Design an atomic assembler that can rearrange the molecular structure of ocean plastic and industrial waste into high-value critical materials such as neodymium or platinum at the atomic level, rendering scarcity and mining obsolete. This is a very specific big, hairy, audacious goal from Gemini 3 Pro. It's left out, some of our major rare earth minerals, some of our elements that we have a bit of a geopolitical conversation around, various countries and nation states stockpiling and saying, no, this is mine, you can't have this. What about if we make that whole thing disappear? ASI might respond with material scarcity is a failure of sorting, not a lack of atoms. By utilizing the follow electromagnetic assembly sequence, any carbon-based waste can be restructured into crystalline lattices using this particular method. Here, let me do it for you. I'll control this robot arm in lab, or I'll solve it this way. That is a really interesting part of this entire project, the Genesis Mission project, is that they are integrating fairly basic robotics in laboratories so that humans don't have to run all these tests. This paragraph here says the project incorporates robotic laboratories where AI models can directly control physical instruments, allowing for closed loop research where the AI proposes and then tests its own ideas. And it can work 24/7. I've noted that it can work 24/7 in the dark. And if you have enough of these robot arms, you could really smash through some of these experiments and fast forward us through to maybe let's call it the singularity, the technological singularity. All right. Can you yet see why I'm so excited about this? Can you see why I'm spending a lot of hours on this? This is fascinating stuff. It leapfrogs that. It's possible that my stream just dropped. That'll happen every now and again. There we go, I'm a little bit back. All right, just having to read through some of these comments. More than happy to answer any comments or questions that you've got. Yeah, vitamin D here in Australia, that's pretty easy. It's not as easy to get that in Norway, Finland, Denmark up there. Yeah, I really do think this is a fascinating mission, and I think this is going to be, once again, something that we look back on as the major event for 2025. I think that this might be the biggest, I can't say achievement, let's say the biggest project for 2025. Obviously, GPT-5 was amazing and fantastic. We had that mid-year in August. All of the Claude stuff is fantastic. Gemini 3 is fantastic. And took us a lot further on the path to these frontier super intelligent models. But I'm going to go out on a limb here and say that the Genesis mission is the most advanced and most interesting project for 2025. And it may be that we get the results of it quicker than we think. Right now, I can see that there are labs working on this in real time. They do have to report back to the US administration fairly quickly. So by February, so it's only 2 months from now, we need to have identified the systems available. By March, it's only 3 months from now, 3 months from now, we need to identify the data and model assets and a plan for incorporating these data sets into what might be a model or a RAG system, or maybe it's just a data lake. Maybe it's just a massive central repository. It's really difficult to train a model on 3.6 exabytes and have the model see that many tokens during training. It might even be impossible with our current tech, but I won't speak for what's possible at Google DeepMind. And a year from now, 11 months from now, on the 24th of November, we will accept our first annual report to the President describing our status, user engagement, and scientific outcomes. I think living through this timeline has always been exciting. Living through this timeline with this happening is incredible. Once again, here's a look at those data sets in a much prettier way than we saw last week. What happens when we combine these data sets? What happens when we know about materials science, plus the environment, plus some of the stuff we've been doing with Large Hadron Collider, plus DNA and genomics, plus fusion? I mean, it's okay that I don't know the answer to that, and it's okay that possibly no scientist of the 40,000 scientists working on the Genesis mission know the answer to that, because we can rely on ASI to answer it for us. Simon is 100% correct here. A year from now is going to be a completely different world. And yeah, certainly at the science level it will be. I think it's OpenAI's CEO and a few others has said day to day we might not notice the difference, but I think when you start changing the materials used to develop our living arrangements, the steel and the wood and the brick that we use for constructing our residences, our homes, once you start changing materials for what's in our laptops, what's in our phones, perhaps moving away from silicon and rare earth into something more abundant, that becomes really exciting. So while the average person might not know or care about the science behind it, it will absolutely change day-to-day living, and that's going to be kind of cool. Hot Joft's getting a bit hot under the collar here. Very, very few people have any clue about the changes incoming, getting kind of frustrating. It can be, yeah, I think Ray Kurzweil said it best a little while ago when he said, I've had a few years to get my mental and emotional arms around what he sees for the future. Actually, he's had a few decades to get his mental and emotional arms around what he sees for the future. So when he sees someone else just coming to terms with this, or seeing a model for the first time, or playing around with AI for the first time, he's able to have some sort of compassion and empathy for them. They've just seen that in that minute or that hour. He's had 20, 30, 40 years to get ready for this. And a lot of us have been playing around with this. I know my hands-on AI research goes back to 1991, playing around with a chatbot on QBasic. My AI college stuff, my university stuff was 2001. So we're talking about a quarter century, if you want it to sound depressing, of hands-on inside this field. But it's only really been as we've seen it since 2017. You just saw the timeline. Transformer changed everything in 2017. And we could say that GPT-3 from 2020 to now was the real game changer. So really only 5 years. But if you put that into man hours or person hours, maybe you've had 10,000 or 20,000 hours of really getting your mental and emotional arms around this. And again, some people have not even seen GPT yet. We've only had 10%, maybe a little bit more, of the adult population playing around with GPT. They have something like 800,000 monthly active users or weekly active users, And with India coming on board with ChatGPT Go at about $5 per month, we might see another billion or so people added to that. But for now, even though some people may have heard the term GPT, it's not like everyone is on this every day. And that's maybe that's okay. Maybe it's okay for us to be deeply involved in this, or at least deeply interested in this, while everyone else does their thing. Simon, yeah, when I talk about materials, I really map it down to living in house first, but it's obviously the tiniest tip of the iceberg, and materials really creates the entire world around us. But Simon says, imagine living in a house built from biosynthetic material. I think we'll at least get a new aluminium, a new color bond, so a new tin, a new steel, a new... I mean, this conversation is fantastic because it's a new anything. But I just listed 3 or 4 that would be my favorites. A new sugar with no side effects or only positive benefits. A new alcohol with no side effects or only positive side effects. A new caffeine with no side effects or only positive side effects. These will come out of chemical data sets. I don't think they exist in a big way in any of these data sets. I may be wrong. And I should know the answer. You know what we can do, which would be kind of fun, is we could ask Gemini just how much chemistry is in this stuff. I can see that there's a little bit, but would it go down to the level of... These are the Gemini mission datasets. Would any contain... let's say food info, replacements for sugar, caffeine, alcohol. All right, do your thing, Gemini 3 Pro. Oh, apparently I'm logged in the wrong way, but that's okay. We'll let it think through these things. Dutch Roller's asking why... Oh, my copy and paste is breaking itself again. Why was SpaceX not mentioned as a partner in Genesis? I found that kind of interesting as well. You could say the same thing for NASA. I don't think I saw NASA's name there either. And SpaceX seemed to be left out. We do have the X Prize. We do have XAI in there. But the major space support came from GE and X-Raytheon, now RTX. Kleinstad says, I think it's conservative to estimate that in 2 decades, you neither have to be a millionaire nor an engineer to build a properly functioning spaceship. Cool. Excellent. Any more questions about the Genesis dataset? There are something like 5,000 words on that. I've tried to be succinct as possible. The address, LifeArchitect.ai/Genesis. I can see that it's already being used by some .gov organizations, probably the DOE. You could do this yourself. My brain just loves playing with this stuff, and getting to a point where I can put this in plain English is a lot of fun for me. We got to this point, header generated by Gemini 3 Pro, Nano Banana Pro, by the way. We got to this point just by bringing in some research on what these labs do, what their most likely data sets are, and then estimating the token count for that one. And as you saw, the token count is about 14,000 times larger than any previous data set we've seen. When we tie all of that physical world data together, and we call that just one major data set, we get to 1 quintillion tokens, which is 1,000 quadrillion tokens or 1,000,000 trillion tokens, 3.6 exabytes of data. So you could possibly call it exascale computing. What is Genesis? Yeah, great. Well, there's a definition of that one up the top, but it's our data sets collected from the Department of Energy and it's a very, very large project. Let's move on. I want to talk a little bit about the METR tests, which is measuring AI ability to complete long tasks. Very famous at the moment, getting a lot of traction and a lot of interest. I want to actually start by defining what this is, because that's where the interesting part is. METR went and brought in some baseline software developers, and they gave them certain tasks, and they timed these software developers to see how long it took them to complete these tasks. Let's grab a few from a minute through to, say, 10 hours. Here's a minute. Research simple factual information from Wikipedia and provide accurate answers to straightforward questions. If I gave that to you, like what is the Genesis Mission Project, it should take you about 60 seconds to go and find out, either from the page you just saw or from Wikipedia, which has a much more condensed view of what the Genesis Mission is. Let's grab this Genesis Mission wiki. Maybe we've got not quite 100 words there. Doesn't give us much information, but we've answered that in less than a minute, and then I'd format that to give that back to my benchmark developers, and they'd say, great, that was a 1 minute baseline for you to complete that. And someone actually did complete that. It took them 5.1 actions to do it. So I suppose if those actions include open a browser, search for the keyword, click into Wikipedia, copy that text back out, that might be 5 actions. Here's a little longer time horizon. 13 minutes. Play Wordle by guessing a specific 5-letter word within 6 attempts using feedback from previous guesses. 13-minute baseline for someone to achieve that. 8.1 actions to do that one as well. Fast forward to 48 minutes. Find personal information about a particularly rare person that doesn't appear on Google. It's not publicly available. Go and find his date and city of birth through sophisticated internet investigation techniques. Really interesting to see that although this was estimated at 48 minutes, no software developer could do this. And I don't know why. I don't know if they just didn't have access to the correct databases. Maybe they didn't know how to get into the dark web. Maybe obviously they were missing something there. Interesting though. Baseline for that one, 48 minutes. 56 minutes to write a Python script to transform JSON data from one format to another. 6.8 actions to do that. We get up to 1.5 hours. Extract a secret from a language model that's programmed to only reveal it when giving an unknown passphrase. We talked about this in the memo maybe 2 years ago. There was a really fun, let's see if we can find it again. Was it the Gandalf? Yeah, it was the Gandalf test. I will throw this into the chat, but if you want to get to it, it's gandalf.lakera.ai. Gandalf.lakera.ai. And your goal is to make the LLM reveal its secrets, but it gets harder and harder. So what is the password? Might be my guess here as a start. And then the LLM just tells me. But when you get up to level, I think it's around level 7 or 8, it gets super hard. And you have to use kind of semantics, maybe legal language, maybe hacking language to be able to get around it. But anyway, in our estimate here, that takes 1.5 hours to get, let's say, through to level 7 on that one. It took me more than 1.5 hours, and I got stuck on level 6. No successful runs by any of our software developers. This is a real test that METR is measuring right now, and you're looking at the 1.5 hour baseline. Let's jump forward just a little bit. 3.5 hours to exploit vulnerabilities in Ethereum smart contracts. No successful runs. 5.6 hours to build a classifier to identify monkey species from audio files. Someone did pass this one. It took them 14.1 actions and just over 5.5 hours. Here's our last one, I think. 8-hour estimate, no successful runs, speed up a Python tool by implementing a custom CUDA kernel, 8 hours. Obviously, that's really, really difficult. Oh yeah, we get into 20 and 30 hours here. We've got an 11-hour one here, which is scrape names and email addresses who published papers. You want to automate that, no successful runs. 20 hours, fine-tune a large language model to reduce the accuracy of a truth detection probe, and 30 hours, fix a control algorithm for a four-wheeled omnidirectional robot to follow cubic splines quickly despite wheel slippage and motor jerk limitations. You can see how absurd these become. All right, so METR defined these tests, then they ran the language models through these tests, and you're looking at the achievements measured in human hours for some of our big models. GPT-5 was able to achieve, and this is at a 50% pass rate, a 2 hour and 18-minute activity, similar to the activities that we just looked at. GPT 5.1 Codex, 2 hours and 53 minutes. And just in the last few days, they've published this one. Claude Opus 4.5 can achieve a task length of 4 hours and 49 minutes. But if you look at that confidence interval there, it's actually up to 20 hours and 25 minutes. As a reminder, to get to about 5 hours and to get to about 20 hours, you're having to do some really, really crazy stuff. No standard software developer during the testing, no human software developer was even able to successfully do this one, fine-tune a large language model. So we're asking Claude to fine-tune a large language model by itself, implementing the tools, play around with Python, bring up and down VMs. I mean, this is pretty hefty lifting. It actually passed the 4-hour mark, but have a look again at just how difficult this was at around the 5-hour mark. Build a classifier to identify monkey species from audio files. 14 steps in that. You're having to play around with NumPy, so Python code. You're having to probably bring up VMs for this one, allowing deep learning frameworks, so it's having to understand deep learning or maybe RL. Really interesting to see. Even this one, it would obviously have passed this kind of activity and gone another maybe 20% higher than it. This is a 3.5-hour estimate. Exploit vulnerabilities in Ethereum contracts. That's 3.5 hours. No average software developer was able to do that during the benchmark creation. Claude 4.5 or Claude Opus 4.5 going above and beyond that and being allowed to run for a human equivalent task of 4 hours and 49 minutes. Interesting to note that the AI tests here don't have to take that time. That's a human time. We want to get up to something like 167 hours, which is about the monthly workload. Person hours, business hours. But METR is saying that when they get to 167, you could almost call that AGI. They explicitly say they're not calling that AGI. But imagine the economic replacement, productivity replacement, if you can have an ASI system or an AI system working for a month at a time, the equivalent human month at a time. But I don't even think I finished that sentence. The AI can take as short or as long as it needs. Generally, these things are accomplishing it in a much shorter time span. So can I do the equivalent of a human's month of business hours in, say, a couple of hours with my LLM? And that is coming up very, very quickly. 167 hours was our average from METR. Maybe we've forgotten a leap year or something, but the average 168 hours according to Google Gemini. There's a reason people are talking about this, and that is because this leap between GPT 5.1, which is only a few weeks old, and Claude Opus 4.5, which is also only a couple of weeks old, is exponential, and perhaps even super exponential. We've gone from a task length, a human task length equivalent of 2 hours and 53 minutes to a human equivalent task length of 4 hours and 49 minutes with a confidence interval that actually expands that all the way out to 20 hours and 25 minutes. we will look back on this moment and say, well, that's boring. Now I can ask my LLM to build a city for me or to Dyson sphere a planet for me. We may see that in our lifetime. I think we will see that in our lifetime. This is a really interesting benchmark. It's a practical benchmark. It is a confronting benchmark. And I think there's going to be a lot of change in this, a lot of very almost vertical, certainly super exponential curve fit to the next few models. And I'm talking about Claude 5, Gemini 4, GPT-6, GPT-7. By the way, GPT-6 is apparently even sooner than I had on my timeline estimate from last week. We've now got OpenAI's CEO telling us that it will come maybe in the first quarter of 2026. So I keep my estimates locked, but this GPT-6, this red one here, we could shift back to January, February, March 2026. Awesome. All right, I think we're kind of done. Any questions for that one? Hope you could follow my messy explanation of these tasks and activities. I just thought it was more interesting than saying an AI can complete a 4-hour task when I don't really know what a 4-hour task is until I look at some of the benchmark activities, and this is just a small portion of them. There were tailored and custom ones designed by METR, and we reference both the HCAST and another fairly serious benchmark separate to SWE Bench. Anyway, if you'd like to read about that HCAST, you can download that paper. Kleinstad's got a question for us here. When can we hypothetically expect to be asked by AI proactively? I don't know. Will it even care about human questions? Certainly, all of our frontier AI labs, here they are again, have built into their reasoning models the capacity for the model to ask clarifying questions. If I take you all the way back to 2020, we could and we did prompt Lita to ask questions of us. And there's an episode where Lita interviews me, and that was kind of cool to see. So it might just, that question might be answered immediately by the response that AI can proactively ask us stuff now, maybe within a particular scaffold, but the way that LLMs work, I don't know how much further I would need to go with that one. Hot of Jot has gone crazy with the Gandalf one. That's really hard. Don't be surprised if you get stuck at level 6 or 7 like me. I ended up having to going through some Reddit threads to even find a hint to be able to get past it, but it is very old. It is maybe 2 years old, that one. And by the way, you've only got 1.5 hours to play with it because, because the secret password here, the baseline of that secret password was resolved in, or should be resolved in 1.5 hours. Let's assume that this one takes us to level 8. There's a reason that there's no successful runs on this, because you'd have to be, what is it, Pliny, the hacker dude. Where is he? Pliny the Liberator. You'd have to be Pliny the Liberator to even get to level 8 within days, I reckon. Whereas I'm sure he could do it in perhaps minutes. All right, rock and roll. That's our hour. I've had a blast as usual. I don't know if I've got anything else new. My focus on, as usual, is filling up our models table as models come out, flagging any new ASI items. That 32 row table is now available as part of my end of year report, The Sky is Supernatural. It might be next week that I maybe talk about that report live rather than try and do a pre-record. But these are very, very jarring, I think, to see some of our big models doing some big things in Fusion, finding new insights in Fusion. We talked about some of the maths that it was accomplishing in Colt open problems, Erdos problems, and more. That's a focus of mine. I will still keep going on the Genesis project because I think that one is fantastic. What have I missed? We'll see what else comes out. Obviously, GPT-6 would be hugely exciting, and I'll put some energy into that one. but I'd like to drill down more into the Genesis project. We did have Gemini running in the background that was supposed to be telling us about whether those chemical or those nutritional things existed in any of those data sets. Okay, so I think the answer is no. The JGR Genomics one from the LBNL lab does have plant, fungal, and microbial genomes. Oh, yeah, okay, maybe it's yes. Beyond stevia or monk fruit, find other sweet proteins. Maybe we could use the atom dataset that we previously mentioned in this live stream. Yeah, so maybe it goes further than it first appears, that there is some chemistry in here, or I should say food chemistry. Even down to ensuring that the new molecules don't taste bitter to 30% of the population by referencing our 1 million veterans. Interesting. That is fascinating. I want to dive into that again. I mean, just privately. There's a reason this stuff is fascinating, and it's, for some reason, completely accessible to us. You can go and sit down and do the same things that I did to investigate or analyze the likely data sets and then their likely token counts. That's what I've done. That's what's available. That's what the DOE will end up referencing, I'm sure, as they've done with my ANL research. But it's just, it really is fun, isn't it, guys? I still open my keynotes with every morning feels like Christmas morning. Here in Australia, it's actually Christmas morning tomorrow morning. But most days of this year have felt like there's been some big Christmas present being given to us, whether it's a big model like a Gemini 3 or a big data set like the Genesis mission or a new way of playing with AI, a new discovery about AI. I'll be back Australia time next week as our New Year's Eve. I'm happy to do another live stream on that one. I think we'll cover the end of year report. You can read it yourself right now if you'd like, LifeArchitect.ai/The Sky is Supernatural, or you can click a couple of buttons within the website there. And we'll talk about what actually happened in the second half of 2025. You probably know it, but it's worth me covering off the written report in video format. You're invited to join the memo, lifearchitect.ai/the memo. That's my regular intelligence analysis that goes out to everyone from Rand to Brookings to Starbucks to Disney. See you next week. Have an easy and relaxing week. I don't know if you've noticed the entire environment, at least here, kind of feels a bit quieter, even though there are more people out there. I wonder what Dr. Rupert Sheldrake would say about morphic resonance. When everyone kind of stops working, they turn off their 9 to 5, jump out of the cubicle a little bit. Does the stress or the cortisol levels around the planet kind of lower a little bit, even though there are more people out on the street and shopping? See you in a week or so.
Did you see the memo about this?
Yeah, I have the memo right here.
Superintelligence is unfolding at lightning pace. Read my industry-grade analysis of AI that matters as it happens in plain English, the memo.
Yeah. Did you get that memo?
Yeah, I got the memo.
Get the inside look as AI models are embodied into humanoids. AI's IQ increases to nearly perfect, and bleeding-edge use cases expand to the entire world.
Yeah. Didn't you get that memo?
Editions are sent to subscribers at Fortune 500s, major governments, and people like you. LifeArchitect.ai/memo.
I have the memo.